we're going to look at the graphs of the hyperbolic functions from their basic definitions. So today's lesson is going to be the graphs of the hyperbolic functions and we're going to have a look at the sketches really from their basic definitions. So I'm just going to underline the title. There we go. So we're going to look at the sketches. Right, okay. First thing I'll do is I'll have some axes here. So I'll put some axis down here and here. So there's basic axis for some sketches. So this is going to be our x axis and this is our y axis. So suppose we had y equals hyperbolic sine of x. Well, from our understanding of what the hyperbolic function is, it's the same thing as e to the x minus e to the minus x all divided by 2. Okay. Well, we could just put this into a graphing calculator or something like GeoGebra, but maybe we could get an idea of what's going to happen in general just by analysing the e to the x function. Okay, well, perhaps the first thing we might do then is look at a key value, maybe e to the 1, look at what's going to happen at the origin. So the sine, the hyperbolic sine of 0 would be e to the 0 minus e to the minus 0 all divided by 2. Well, that would be e to the 0 is 1 minus 1. E to the 1 minus 1 all divided by 2 is 1 minus 1 all divided by 2, which is going to be 0. So we know that the hyperbolic sine function will go through the origin. So what happens next? Well, one of the things we might look at is what happens as x gets large. So we're going to think now about what happens as x goes to infinity. So x is going to get really large. So essentially we're going to see if we plugged in a really large number in for x, what would happen? Okay, positive number, really large positive number. Well, if I did that, e to the x, so as x tends to infinity, e to the x, that also goes to infinity. It's going to be a big number, okay? As x tends to infinity, e to the minus x, that will tend to 0. That will get really small because it's basically the same thing as 1 over e to the power a large number, okay? So if we put in to this, what's going to happen is this term here, as x gets really large, will essentially just not be important. So for really, really, really large numbers of x, this is essentially almost the same as e to the power x. So what we're saying is, increasingly, as we go this way, the graph is going to start to curl up like that and become looking like an e to the x graph. Okay. What happens when x goes to minus infinity? Okay, so what happens when x tends to minus infinity? Well, essentially the same thing is going to happen, but in reverse. E to the minus infinity, that's going to become 0, minus, and this is going to become a really large number. So to all intent and purpose, this is going to look like minus e to the x. Okay, so it's going to come down and curl down like this. So the graph of hyperbolic sine looks a little bit like a cubic. What we say is, as x tends to infinity, then the e to the x term dominates. as x tends to minus infinity, the e to the minus term will dominate. Okay, so we've got this straight away from just looking at, thinking about what will happen. Okay, what we'll do is we'll check that now using GeoGebra. Okay, here is our graph of y equals the hyperbolic sine. I've just typed it up into GeoGebra, and you can see that, as we suspected, the hyperbolic sine is 0 at the origin, and as we go to the right, as x gets large, positive, then the e to the x term dominates. As we go to the left, as x tends to minus infinity, then the e to the minus x term is going to dominate, because minus a minus large number is going to be a positive number. Okay. Okay, I'm going to draw another set of axes now, and we'll do the cosine. So I'll have something coming down like this, and like this. Okay, so remember or recall that y is equal to the hyperbolic cosine of x. That's basically saying that y is equal to e to the power x plus e to the minus x, all divided by 2. Okay, so we'll put an origin. This is an x-axis, this is a y-axis. So from the same reason as before, as x tends to infinity, so as x goes to infinity, then the e to the x term will dominate. Okay, the e to the x term will dominate. This time, the e to the minus x will turn to 0 again. And so again, this is looking very similar. But one important difference is, at x equals 0, then we're going to have y is equal to 1 plus 1 over 2. E to the 0 is 1, e to the minus 1 is, sorry, e to the minus 0 is still 1, so it's 1 plus 1 over 2, which is 1. So this, the e to the, y equals hyperbolic cosine is going to go through the point 1. And as we've just seen, as x gets large, the e to the x will dominate. Okay. What about as x tends to minus infinity? So as x tends to minus infinity. So as x tends to minus infinity, what's going to happen? This term here is going to be 0. This term here is going to be effectively the same thing as e to the x, except it's going to be traversed this way. Okay, the divided by 2 is going to scale it, but it's going to be increasingly not noticeable. So it's going to curl up this way. If I can do it. There we go. So this is the graph, or a sketch of the graph, of y is equal to the hyperbolic cosine, cosh. Okay. Again, I'll just pause this and I'll show you on GeoGebra. Okay, I've just put on the y equals cosh function, so you can see again comes through at 0, 1. That's the here, because the e to the 0 is always 1, so the 1 plus 1 divided by 2 is going to give you here. And as x gets large, the e to the x dominates. As x gets large negative, e to the minus x will dominate, and so it's going to come up here like that. Okay. Just for comparison, there's the e to the there's the hyperbolic sine. So you can see actually, as they both get large, they almost turn into the same thing. Okay. Okay, so the final basic one would be the hyperbolic tangent. So I'm going to draw some axes again. Okay. So here's my x, here's my y, here's my 0. Recall the definition of the hyperbolic tangent is the hyperbolic sine divided by the hyperbolic cosine. So which is going to give us e to the x minus e to the minus x divided by e to the x plus e to the minus x, sorry. Okay, so this is the y equals the hyperbolic tangent. Okay, so y equals the hyperbolic tangent is the same thing as hyperbolic sine divided by hyperbolic cosine, which is e to the x minus e to the minus x divided by e to the x plus e to the minus x. So again, we probably all should start with the origin. So at x equals 0, and then what we're going to have e to the x, which is 1. E to the 0 is 1. 1 minus 1 is 0. So it's just going to be 0. This is going to cross through at the origin, like this hyperbolic sine did. Okay, what about as x tends to infinity, gets large to the right, so positive infinity? Okay, well, what's going to happen? Well, this term here, let me undo that. This term here, nope, that was bad. This term here is going to tend to 0. This term here is going to tend to 0. So we're going to end up with essentially e to the x over e to the x, which is 1. So we're going to say that the hyperbolic tangent, as x tends to infinity, the hyperbolic tangent will tend to 1. So we're going to end up with an asymptote now. So let me just put that on here in red. So maybe there is 1. Okay. So our graph's is going to come up like this and tend towards 1. Okay, so this is y is equal to 1. Okay, what about as x tends to minus infinity? Okay, so as x tends to minus infinity, well, this time this is going to turn to 0, this is going to turn to 0, these are going to cancel out, but we're going to end up with this residual minus sign. So it's going to end up with minus something divided by the same thing, which is just effectively minus 1. So we're going to need another asymptote this time. So we'll put an asymptote in the same place. What was that? 3 squares. Let's go here somewhere. Okay. So this time now it's going to come down. It's going to come down. And it's going to curl like that. Okay. So this is the graph or sketch of the graph of the hyperbolic tangent. So just to kind of get them all together now. Hyperbolic sine, hyperbolic cosine, hyperbolic tangent. Now there are obviously the inverses of these, which I'll deal with in another video. But for now, these are the ones that we need to remember. Okay, I'm just going to show you what this looks like using GeoGebra. Okay, here's the graph of the hyperbolic tangent, and you can see it has the feature that it's going to flatten off with an asymptote at 1. Okay. At y equals 1, y equals minus 1. So for completion, here are all the graphs. Okay. So one at a time. Hyperbolic sine looks a bit like a cubic, goes through the origin, dominated by e to the x. As we go large, dominated by minus e to the x as we go large and negative. Hyperbolic cosine goes through 1, dominated by e to the x, dominated by, well, it's reflection of e to the x here. Okay. Finally, the tangent. There we go. It goes through the origin, has an asymptote y equals 1, and an asymptote y equals minus 1.